All right, so today we're going to talk about the product of powers property, right? So product means, that's, right, this is the result of multiplying, right? And powers is another word for exponents, right? So if I say like 5 to the second, right, this is 5 to the, well, I said to the second, right? 5 squared, sometimes we call this second, right? Second power. So this is just another way of like referring to exponents. So you need to understand when we say to a certain power, right? To the power, if it was like to the power of 10, to the power of 100, we mean that the exponent is that value, right? So this is to the second power, to the third power would be 5, right? So if it was, right, this is, this we would say this, if I said this out loud, I would say this is 5 to the third power. Okay, so the product of powers is, say we were going to take these two numbers like this, right, and we're going to multiply them. Okay, so the product of powers. Okay, so this is what we're talking about, the product of powers. So we're going to come back to this in just a second, but what we're going to do is we're going to look at on page 34, right? We are going to look at some equations or some examples, and we're going to use these patterns to come back and talk about the product of powers property. Okay, so we notice, right? So again, see this little dot, right? So I would like you to make sure that you guys realize that that means multiplying. Okay, so this is 3 times 3 times 3 times 3 times 3. So this is 3 to the, right? There's 5. There are 5 of these. Right? There's 5 of them, right? So this is going to be 3 to the 5th power, right? So we would say this, if I said this in words, this is 3, not tree, with a TH, 3 to the 5th power, right? Okay, so what they've done down here, all they have done is group them. Okay, so I'm going to pick 2 different colors here to kind of point out the grouping. So, right, they have grouped these 3 or those 4 together and then left this one out here. And, oops. So, right, there's 1, 2, 3, 4 3s multiplied together there. So this is 3 to the 4th power times, right? So I would have put maybe like a multiplication here, times, and then just this 1 3 all by itself. So 3 to the 1st power. Well, there are still 5 3s multiplied in a row, right? So this, right? So if we take all of this together, right? So if we look at all of this together, which is the same as all of this together, well, then what is this? This is 3 to the 5th power, right? There's still 5 3s being multiplied in a row. Well, what if those numbers were grouped in a different way? Right? So what if they were grouped with, right, these 3, I'm looking for a different colored pen, right? So right here, right, these 3 are multiplied in a row. So this is 3 times 3 times 3. So 3 3s, right? And then times, right? And then over here, right, we have these 2 3s that are multiplied in a row. So again, I'm putting this multiplication symbol right here so you can kind of see that is this right here. But so there are 2 3s multiplied in a row. We can show that with an exponent of 2. Right? Well, what do we still have? We still have, if we were to look at it, right, these 5 3s multiplied in a row, which is these 5 3s multiplied in a row. So this is also 3 to the 5th power. Okay, so we have 4 and 1 is 5, 3 and 2 is 5. So, right, what pattern do you see when multiplying 2 powers with the same base? So notice, right, same base. And we talked yesterday about what the